we're going to continue learning about exponential and logarithmic functions. In this lesson, we're going to learn to evaluate common logarithms. We're going to use common logarithms in application problems. We're going to evaluate natural logs, which are going to be used more in financial calculations. We're also going to work on natural logarithms and applications, as well as a change of base rule. So the great thing about this section is that we're going to be going back and utilizing some formulas. So you're going to want to take a few notes, not a lot, but there's going to be a few things you're going to want to take down so that as you're working through 10.5 homework, you're equipped to do it all. So the first thing is we want to be able to evaluate common logarithms using a calculator. There are limitations on what we can actually do with a calculator. We can only evaluate logarithms that are considered to be a base 10. So notice how there's not a number written here. Remember when we have just x, we say that 1 is implied to be in front of x. When I don't have a base written, it is implied to be 10. So when I'm typing these into my calculator, it's really log base 10 of 41,600. I could not calculate log base 2. So when I type this into my calculator, I get a long decimal. The habit is to evaluate it to 4 decimal places. So we're rounding to that 4th decimal place. The same thing occurs in part B, and we're going to round to that 4th decimal place. And then in C and in D. So notice how in D, I just use the exponent key. That's the beautiful thing, right? This looks really tricky, and there is a property I can use to simplify it, but I can also follow up in my calculator and double check myself. So how do we use common logarithms in application problems? And then this slide goes, whoa, when you look at the slide. So we utilize logarithms a lot with pH. So if you're going into a field where you might see nursing or medication pharmacy, chemistry, any kind of chemistry application, you're actually going to see logs. So you might actually take a class where you have to do chemistry, and we're going to talk about logarithms there. So let's find the pH of water when this is the concentration, and then we'll know if it's a rich fen, a poor fen, or a bog. So to do this, I'm going to do, the formula is pH is the negative log of my concentration. So I'm going to replace that with my concentration. I can separate that. You could also probably type that in your calculator right from the jump street, right? And get this. So when we get 2.9, we could just literally type this in here and get 2.9. Then where does that put us? That puts us in a bog. So you don't need to use the properties to separate this if you're doing an application problem. You can just type this step right here directly into your calculator. Now, if I want to know what the concentration is, when I know the pH is 4.6, then I'm going to have to do some non-calculator based work. I'm going to say that's log base 10. So this is kind of tricky, right? I'm going to take 10 to the negative 4.6 and 10 to the log base 10 of this. So the 10 here raised to the log 10 cancels out, and that's where this comes from. So it's kind of like the idea of what you do to one side, you have to do to another. So I'm taking a base of 10 and raising the left and the right as the exponent. But on the right, my property is going to cancel it out. Decibels is another area we see with a common application of logarithms. That's how loud something is. And so here are some common decibels that are heard, the different ratings of loudness for an object. So if I want to find a decibel level to the nearest whole number of a whisper, I'm going to do my 10 log. I'm going to plug in. I get 10 of log 115 because the I naught divided by I naught cancels. I can type that in my calculator, and I get 21. And then you can go back to this table to see 21 is pretty quiet, right? It's very far below normal conversation. Natural logarithms are Ln. So when you start seeing the term Ln, that is our natural logarithm. The implied base of Ln is e, not 10. So that's the distinction between a log, log, and a natural log, Ln, is the base. So we're going to approximate e. to be this value, and very much like pi, it's a universal constant, so it's never ending. You can utilize the button on your calculator for e that is typically above the natural log button. So we're just going to type into our calculator, round to 4 places. Type in your calculator, round to 4 places. This is not different from the log functions. It's the same thing. Our calculator can calculate the natural log with a base of e all by itself. Now if we want to use them in applications, the biggest application of natural logarithms is in finances. So a lot of your financial math fields, even accounting, onto actuary math, onto marketing, there may be some different applications of natural logs that are being applied in those different fields. So, but I can actually look at this equation, and I have a natural log in it, and I want to approximate when x is 700. That's a straight calculator. A lot of these questions in the labs, guys, we are just replacing x and typing it in your calculator. So don't freak out when you get to the word function. Take a deep breath, walk away for a minute, come back with fresh eyes. Most of these are calculator punch problems. Now this is the change of base rule, and this is why this rule is important. I can't use my calculator with a base 2 log. I can use my calculator with a base 10 log. So right there, that's the importance of the change of base rule, is I can actually work with something where I can get a numeric value for it. Because saying log 20, well, what does that really mean? What is log 20? Where does it fall in the grand scheme of things? So we do this a lot so that we can utilize it. So if you look at this, I have log base a of x is equal to the log base b of x and log base b of a. So the a becomes the denominator, the x becomes the numerator. If I was going to choose this, I would do this as log base 10 of 13 divided by log base 10 of 2. So I can type it in a calculator. Log base 18 divided by log 6. So I'm using that base 10 there. Same thing here. We're converting that over to base 10 to actually get a number value so we can have some understanding of what's happening. And that's the end of this one.